All right. Well, welcome everybody to the Houston Java User Group first meeting for the year 2025. We've got Yugo Sakamoto here today, and he's going to be talking to us about how to do that AI thing. He's gonna get us introduced to it. I'll let you just take it away, Yugo.
Okay. Oh, so thanks a lot. Thanks a lot, Scott, for having me today. Thanks everyone. Yeah, I'm very happy to be here, uh, sharing, talking about the this topic, generative AI. I do usually talk about generative AI, especially for software engineers, because there is a where I came from, right? I'm a software engineer. I've been I was talking here with Randy on the backstages, and I'm also a developer that is, I may say, full stack. I work it on the front end. I also have the experience on the back end first, and then now I'm playing with AI and creating solutions that connect all these models that have dominated the market nowadays, right? The industry nowadays. So, yeah, I think that's the goal for today. We'll try to introduce generative AI, but in the point of view of a Java developer. So today the idea is to explore some of the features that is very common when we do start creating these solutions with Java or with models, but using a Java stack. And yeah, I think that's uh, that's the intro, Scott. What do I think I can I do you want to say something now, something more?
Do we need like a development environment to follow along, or
Oh, yeah. If you want to, I have the GitHub repository. Uh,
okay?
but I'll be showcasing all the things in the with the uh, within my screen here. But let me check. Let me get the repository address and share with you.
Yeah, put that in the chat, and I will.
Yeah, I'll paste on the chat. Uh, just a minute. Um, this is actually a workshop repository. So if it is made for you to try yourself if you want. Um, I just pasted on the link here in the chat.
Okay.
Yep. So feel free. It is the instructions. It is in Portuguese, but they're pretty straightforward. The instructions, so I think it won't be the blocking part. So you can just go on and execute the commands. And yeah, let me see here. Let me share my screen. So I think I can start sharing my screen, right, Scott?
Yes.
Cool. So yeah, here we are, GenAI for software engineer. All you need to know to build intelligent applications with Java. Yeah. So I always start with the definition part, but I know that I've been already 3 years already talking about generative AI, so probably most of you already knows. So let's move quickly here, and let's take a look about generative AI, right? What everyone's talking about generative AI. If we do explore the AI field, we may find a lot of different fields and then to get into generative AI, and there are different techniques also used to make these models, build these models. Yeah, it is difficult to talk in the very details everything that can that generative AI can cover. So I will use a very much simpler definition that is the most common in the market. So that is the view of generative AI, where you can find it when we talk about inside the AI field, right? So I just say I need to say sorry for the Portuguese definitions here. So let's just focus on the audio and the and the titles. So let's start with the artificial intelligence. So what is artificial intelligence? It is the field that studies techniques that can simulate, emulate any human skills, right? So we can find lots of things here. Computational vision from learning styles and so on. So one of the things that we do find when we want to look at generative AI, it is specifically this skill of learning that we do try to simulate with computers. That's specifically the field of machine learning. So that is what it means. It is the study field that studies the techniques to try to make computer learn something from some data and identify the patterns or the group, the clustering stuffs, and then it can classify things. It can identify, classify, identify groups of these of the amount of data. And one of the techniques also that is present in the machine learning is what we call deep learning. Not so many years ago, it was one of the revolutionary techniques that we find that is specifically developed to use neural networks, but in large scale and without having to supervise every label for identifying patterns. So by doing that, it enables those neural networks to identify more complex patterns because we can feed it with a huge amount of data and then let the machine figure out what is the patterns that that is relevant for this data, so it can do stuff like classifying, grouping, clustering, or identifying stuffs. And then with deep learning, we came to the generative AI that is specifically to start identifying using deep learning, using these neural networks. It can now not just identify these patterns, but also use these patterns to generate new content. And that was when emerged of this boom that shaked the industry. So it is the ability to generate stuff over something that it learned from the best data, from the data that we gave for this to feed these models. And then, so with that, we can. It's very common to divide what we call the traditional AI techniques and the new generative AI technique. It is traditionally we do use a lot of these AI algorithms to discriminate something. So to identify, if we have a picture of a dog, we want to classify or to identify what is this picture about, and it is a dog. And with generative techniques, instead of classifying, it does identify that it's a dog, and then it is able to generate a total new picture from that. So that's now a common separation of these techniques, what we see from traditional to the new generative AI stuff. And yeah, so by doing and when we talk about generative AI, it is very common to talk about large language models, that is the models specifically built to generate, to understand natural language and generate new text, new natural language content. So if you, it is nothing else than a neural network that was trained with lots of data of text from books, articles, code, anything that it could be interesting to feed this model, and then it is able to identify the patterns and then generate new text. So nowadays we do have these big models as the most strongest models in the market. We have the GPT from OpenAI. We have the Grok from X, or the old Twitter. We have the Cloud, Gemini from Google, Llama from Meta AI. Those are these large language models. Those are these models that is very, very big and very difficult to, you probably not, you won't be running in your computer. But we do also have smaller models that can fit in your machine, and it is what we're going to be using today. A bit slow if compared to the services that we usually use for these models, like OpenAI. They do provide the GPT-4o, and probably have a very specific infrastructure that can run it really quick compared to something that runs on my machine. But yeah, that's but you can also use these models to place in your any on-premise server on the cloud that you can host yourself, or you can host, you can pay for that. And we do also have those small language models that can fit also into smartphones and any other devices, smaller devices like IoT devices and so on. So it's interesting to have an eye here on the small language models. Both those small language models that can fit on a phone, but also these models that can run into your computer. Lots of things are lots of studies to make it more performatic, more optimized, have been advancing and have been giving more space for these kind of models. And as I said, what kind of content it is, those models are fed from many different contents. This is a image from GPT-3. All of this I took from livearchitect.ai. I do recommend, if you want to keep updated with the latest news about these models and these generative models, you can be watching there. It's really good content. Yeah, so it does get content from all these places and many others, million of other domains, to learn the patterns, and the relations of the words or tokens that exist from those contents. We do also have open source and closed sources models. I think at this point you already figured it out, and we can run it using different local runtimes. Nowadays, I see a lot of people using Llama for their as a local runtime for these models, an engine for these models to run these models in your machine. Today, I will use LM Studio because it is a much user-friendly application with nice UI. So I think for first-timers, it's much more welcome than command line interface of Ollama. And then we have the Hugging Face. That is the place we do most of these open source models comes from, and people share there. It is like the GitHub for the machine learning and the artificial intelligence guys. And yeah, the important stuff about large language models, it does generate text. It is pre-trained, so it does what it learned. It was from what it has been trained from. So it doesn't learn new thing on the fly. They are non-deterministic, so they have this behavior. We can of course handle it and strict it a bit, but the original idea, it is natural to be, for neural network, it is natural to be non-deterministic, and they have an input or context limit. So that's some aspect that is important to know about these large language models. And yeah, so how we do actually connect with these models. And now I will share my screen. Let me do the following. Let me share the whole screen here for better experience for everyone. Here. So Scott, I think you're seeing the whole screen now. I think. Let me put myself here at the top.
You're good.
Yeah, cool. Okay. So if you want to follow up the code that I will be showcasing here, you can come here on the GitHub account, workshop Langchain4J, the link that I pasted on the chat, and you can clone the code here. As I said, it is it is in Portuguese, but I think you won't find much problems to follow up with the code. Okay, and yeah, so let me just come back here to the presentation, then go back to the code. So the first thing, if we do want to work with these models, the first thing is to connect with them, right? They are models they are neural networks that will be running into some engine like Ollama or LM Studio, or some server, remote server, as we do when we use OpenAI services, for example. And here, the example uses Java 21, Quarkus. Quarkus only for the last, in the end of this presentation, I just showcase how to use some things that we have developed during the presentation. And I also use the Langchain4J, that is a library to help us connect with these models, okay? So the very first thing is to connect with them, as to write a hello world in Java and then print what it does, whatever it does, give us back. Okay, so to do that, actually, before going to the code, any questions from anyone here on the chat or on presentation so far?
Do we need any accounts for this the OpenAI LM Studio or anything to use
cool. It? Yeah, for OpenAI, of course, you're gonna need to create the account and get the key. But I will showcase how to run on our own machine. So okay. So yeah, for LM Studio, you won't need to create any key, anything. But you need to at least install LM Studio into your machine. And once you install it, yeah, that's great that you asked it before, because I was right jumping to the code, but there's a setup that you need to do. So LM Studio, you can find it on if you type LM Studio on Google, you can find it. It's lmstudio.ai, and you can download the executable from any of the platform that you use to run it. Okay, and once you install it, it will, and open it, it will show to you this interface for to interact with it, with the LM Studio. And the very first thing you need to do is to find a model for you. So we come here to the discover option, and then we do search for the model. I searched for Llama 3.2. That is slightly small model, and I'm able to run in my own machine. And instead of getting the original Llama 3.2 from Meta, I got this Hermes version that is compatible with function calling inside the application. So, but I will enter into function calling in a few slides ahead. But let's just download some of model. I choose this one. You can download many models, different models that is available on the Hugging Faces. It is just connect directly to Hugging Face and can give you the list of models that you can actually use in your machine. We have also this 5.4 from Microsoft, DeepSeek. It's an open source model created to compete with the O1, the O1 version, O1 model from OpenAI. So it's a model that is focused on reasoning capability, okay, and so on. So let's go back here, Llama 3.2. You can just click here, and when you have a model that is not downloaded, you can just hit download here and then use it, okay? So once you have downloaded it, the next thing you have to do is to go into the developer field and select the model that you want to load. So I want to load Hermes 3.2, load model. Oh, I think it's already loaded, sorry. Here it's loaded. But if it wasn't loaded, you can load it here. And then you can just, here is the server setup. So you can just hit the button here to make it available, and it shows to you where it is available. So it's reachable at localhost 123. So if you copy the localhost and paste let me check here the V1 models. Yeah. A valid endpoint is 123/v1/models. It will list the models that is available on my on LM Studio. So I have all these 4 models available here, but I just loaded the last one, the Hermes Llama 3.2. Okay, and that's already just to check if everything is working on this server. Okay, if you have it done, we can straight go to the code and take a look on the project. Let me close all the tabs here.
So this LM Studio, if you don't mind me interjecting, how do you determine that it doesn't talk to anything outside of it?
Anything outside of it?
Yeah, I mean, you're running a LLM locally with it, right?
Yes, exactly.
So how do you guarantee it doesn't send out anything?
Oh, well, the application is to run locally offline. So of course, if it is something on the LM Studio that is a code that sends something for outside, it is a malicious code, but it is a application that is very already well used in the community as well. So you can have fair reliability on them. But of course, like any other application, it can have some hidden code that might be malicious. And then if you are asking how can I actually see if it's not sending any information that it shouldn't for any remote server, probably I need to open a network monitor like I should do with any other application to really check if it's not doing anything behind the scenes, right? But the idea is not to do that. So it's an application that is specifically to just run your model and run it locally without having to connect offline. I actually can disconnect to the internet and try to run it locally to see if there's any error code with that.
Yeah, no, I mean that's exactly what I would do. I just unplug the cable and run it.
Yeah, yeah. But the idea is all these open source models that you use these engines to run it, they don't rely on internet to run it, and that's so true because I used it during my travel with offline computer because I haven't I didn't have the internet that time, and I used this model to help me with some job, some work, and it worked very well. So yeah. They are pretty reliable applications nowadays. But of course, I will rely on well-known applications such as LM Studio or Llama, local AI. I see that's used by many, and if such kind of malicious code inside it, probably a high chance to detect it and also being reported. As normally it is on open source community, at least for these big players on the open source. That does it does it respond? Yeah, good. Okay, but thanks for the question, Randy. Fair. So it is running. Now I can go back here to the IntelliJ. Once you have found the GitHub repository, you'll get this project, this whole project here. And yeah, what do you need? What do you need actually to run a Java application to connect with these models? So one thing that I said is to use Langchain4J. Langchain4J, it is a Java version, open source community version for the Langchain. And that is one of the most popular API or library to integrate with these models on Python and TypeScript. And the community created the Langchain4J version. And if I'm not wrong, it was the guys from the Focus also helped a lot on the graph of this library as well. And yeah, what you need to do is only add the Langchain4J library and the Langchain4J OpenAI to connect with the OpenAI. And why I do use OpenAI here, since I say that I will connect with LM Studio, is because LM Studio does follow the same specification of OpenAI for their API. So if I do here and want to create a chat model from the OpenAI, I have to give a API key. Here you can run a demo key, so you don't need to create an account by yourself and create an API key. Of course, it is a more limited API, but it works as well. So you can use the 4.0 mini for this demo application. And if you want to use the LM Studio, all you need to do is to create OpenAI chat mode, the same builder, and just set the base URL to be pointing to your localhost 123.4 and /v1. And the API key, you just need to put the API key because this builder, it does check if API key is required. So you can put anything here, anything here, it will work. And my recommendation is to also set a timeout, a larger timeout than the default, because running locally takes more time. So yeah, that's all you need to do to start setting up and using this model. And how do I use it? In the same project, if you go to the test folder, I prepared 2 test integration tests for this project. So one is the workshop OpenAI test, and the other one is the local test. Let's open the local test and take a look on it. I hope the code, the size of the code is all fine. Everyone can see it clearly. Or it's better to increase the size. Better now? I hope it's all good. Okay.
It's pretty good.
Pretty good? Okay, cool. So once we do have this AI model factory that I wrote as a util class, we can just call it create local chat model. It's exactly what I just created here. And with the chat model, all we need to do is .generate and ask the question. So write a Java hello world and see the result of it. So let's just run the test here. And the interesting part when running the test here and having the LM Studio open here is that you can actually see the call coming from the application and then the model generating the response. So right now it is generating the response. So the time it's taking, it is actually for the model to process it. And then that's the response from the LM Studio. It just gives me the message with the response of that query that I just made. So I do print it. So if you come here and see, you can see the write a Java hello world, and then here's a simple hello world. Why I can't navigate here? Okay, that's why. Good. That's a simple hello world in Java. So Java public class hello world, system print out hello world. Okay, so this is the very first step you need to do to start playing with these models. And as you can see, it's very simple, right? Just need to set up the URL and put the model to run on your machine, and then you can already play with it. And since you're running it locally, it is on all. It runs all offline. But if you want of course, if you want to run something more powerful, a powerful model, of course, those models from the OpenAI is much better. If you run it here, let's just run for comparison. So I haven't put the time to start the application and the time to respond here, but of course, much quicker than running locally in my machine, and a much smaller model that I was using here. But pretty same output, right? Programming Java, hello world, of course, writing hello world probably the most common class in Java that you might find on the internet and any other place, right? But okay, let's just move on. Any questions so far? Good. Okay. Well, so it is just a comparison. LM Studio, what you need to do to instantiate a chat model, pretty similar to what you do with OpenAI. OpenAI here, I changed it to demo API key, so you don't need to create your account on OpenAI. I can use it to try out some outputs from the model. Of course, this demo key, they probably are using cached responses, so not exactly the same as you using your own API key and running the in the GPT-4o from your account. Okay. So yeah, let's go to the tokens. So language models, every input that does receives in language models, they are processed by tokens. And tokens is nothing else than a block of text, but not necessarily an entire word. It is a division calculated from. There is a model to actually specify the tokens. What is the tokens, and it is calculated to be more effective on optimize the definition of these tokens to process into the model. Okay, so one example here of optimization is to separate ization from any other word, because ization we can use tokenization, we can use on clusterization, we can use on any other ization suffix. So yeah, that's it. So that's why not the input or the models doesn't exactly process word by word. They process token by token. And yeah, for also when we do define prompts or this input, we can, of course, they're all strings, so we can also prepare some templates and then just do some kind of string concatenation to reuse some instructions into our models. So this is a very simple example. If I want something to be to debug everything that I do pass to it, and I always pass some piece of code, some snippet of Java code, for example, I can actually pre-configure the, can you identify any bugs in this Java code snippet, and just concatenate or just use a string template here and concatenate a piece of code that I always pass. So it will save me time to not needing to rewrite for every prompt the same instructions, right? So if you go to the test 2 here, it's exactly that implementation. Instead of writing the whole instruction into my input, I can prepare some class here. I called it debugger assistant, and I give it some instructions that, and then I do replace only what I need to change into there. Very simple example here. So it is a debugger, and I can actually just pass the code and ask to debug it. By the way, anyone here could identify the issue on this piece of code? Everyone Java developer, right?
I'm missing semicolon.
Sorry?
Missing semicolon.
Oh yeah, perfect. Missing semicolon. Yeah, that's it. So I just asked it to debug this code, and let's see what it does. Snippet has syntax error. Correct. And so I don't know why, but this model always get it wrong. Although it does rewrite with the semicolon, it does get the error wrong. And that's interesting thing. I think it was Jim. So thanks, Jim. Yeah, you're right. It was the semicolon that is missing. And but you can see here that's very simple debug task here, and the Llama 3.2 just failed to identify the correct error. Actually, it just says the missing parentheses were causing an issue, parsing the code as intended, and that's not the case. But it is important to know that if you run it on GPT-4o, then it should get right. Semicolon, missing semicolon to the end. So I don't know why, but these smaller models, that every smaller model that I tried out, it does miss this simple example. I don't know why. But yeah, that's the difference between working on smaller models and larger models. Larger models are usually more comprehensive and more smarter than smaller models. Good, but that was a simple example just to share about prompt template and this difference of small and larger models. But let's do something more interesting here. Let's talk about memories for these models. So an important thing is that these models, large language models, doesn't learn from user inputs on inference time. At least these pre-trained models, such as GPT, they can't. They just learn that on the training process during the training training step. So how does it actually work? Everyone have seen that ChatGPT, if you talk with ChatGPT, it does remember everything that you talked on that chat. But if we do this, if we do just write things for the model, like GPT-4o or any local model, if we do ask, if you do start saying that, oh, my name is Anna, and then I ask, what is my name? It will just don't remember. Let's just prove it by running an example from local here. So if you go to the tree, to the example number 3, I have the chat model. I will ask first that I am Java programmer, and then I will just ask in which language do I program. Let's see what it does output for me. So I'm a Java programmer. I'm waiting the model to generate the response. And yeah, that's great. Welcome to the Java community. Oh, cool message. Do you have any specific questions, blah, blah, blah? And then I ask it, in which language do I program? And the response was, it appears that you are referring to yourself and asking programming languages used. If you didn't specify, it's difficult for me to provide an answer directly. However, if you want my opinion, based on the way you phrase the question, what? With capital I and additional context, I will assume that you program in Python. Okay, I don't know where it came from, but okay, fine. But we can see clearly that it doesn't remember anything that what I just said to the model, because these models they are just stateless. And well, so how does ChatGPT actually work? How it remembers all the messages on the chat? And the difference is that instead of providing only the prompt, ChatGPT, let me go to the slides here. ChatGPT is actually an application that uses the model. So what happens is that, hello, my name is Anna. And then the application sends the hello, my name is Anna message to the OpenAI, and it does reply with, hello, Anna, how can I help you? And when I ask, what's my name? What the application does is to keep the whole history of the chat and just concatenate the last message that you just added. And then it does send the whole history of the conversation to the model. And then the model answers as it should answer, completing the chat here. Okay, so that's the way it does memory works. It is managed by the application, not by the model. And let's see it here. So it's as simple as an array of messages that it keeps and then send all at once. So if we do, I created a class called chat assistant. If you go here, I keep a instance of chat memory. As I said, it is just a array of messages that has 10 slots, and then it will be a sliding window that will clear up the oldest messages and then keep the last 10 messages of the conversation. And the only thing that chat does is getting the message, add the message to the array. When I do call the chat model, I do send the array of the messages. And then I do add the AI message response to this array and give the message as well to print later on the test. And that's all. So if I do run this version now, Scott, how long do I have?
I mean, go ahead.
You have at least 45 minutes.
45? Okay.
Yeah,
So
you have as long as you like.
okay,
So,
that's good.
This is what we talk about with context of AI, right?
Yes, that is.
So you have kept 10 contexts back, and at that 10th, they forget that 11th prompt.
That's true. The 11th message on the conversation. Yeah, that's true. And then, whoa, it just generated a big message here. But okay, but yeah, that's true, Randy. And that is the most naive implementation of this memory. Okay. Now, after this, we're gonna be exploring what we call RAG, that is the retrieval augmented generation, and it's more interesting to see it working. So here, what I did is I'm a Java programmer. It generated this huge message here, response here, okay, about Java. And then I said that in which language, I asked it again, in which language do I program? And the answer was, it seems like there might have been a misunderstanding. Based on information you have provided so far, it appears that you're already a Java programmer. Okay, so it does see, it does not remember, but it is considering the first message that I asked for them. I asked for the model because I just sent in the whole conversation to them. Okay, so that's the way it works to have this continuous conversation. And oh, that's an interesting thing. If we do go to the LM Studio and see what it does receive it on the last last prompt. Let's see here, my requests. This is the generated prediction. Oh, it just I put it to print only the response. I should have put to print the where can I set it up? Oh, sorry, I don't remember where do I set up. Actually, it changed a bit from the last version that I have used it before. But probably I wish to show the messages, the array of messages that the server receives, but it stopped to print the request from the client. So yeah, unfortunately, we cannot see it now. But okay, so that's as I said, this is how memory works. And with that, we can do lots of things we can think on lots of things here to optimize, as Randy said. If we do have, if I do use that bucket of 10 messages on the chat assistant, it won't last for too long. If we do, if I am Java programmer, and on the 11th message I asked, in which program do I in which programming language do I program and do I use? Probably it missed the old context, and then missed the response, the correct response. And to deal with it, we have some smarter way to address not just memory, but context. So it is the well-called retrieval augmented generation. That is a lot of everyone talking about it. And actually, it's a cool name, but it's very simple way to address this kind of issue. That is when the context grows too much. So to understand RAG, I like to separate in 2 steps. The first one is to organize the context. So whatever the memory or the historical data or the context, some book, some big book that you want to ask things over that, we get all these texts, and then we do break it into small chunks. And the chunks you can define as you want. So there's many ways to organize it, and the best way to retrieve the information back. And once you have separated this content, you can you use a embedding, what we call embedding model. I'm going to speak more further, but it's nothing else than transforming this chunk of text into numbers, into what we call vectors, an array of numbers. And then we store this array of numbers on something probably you already heard about, that is vector database. And once we have the vector database with the vectors and mapping to the content or the text, the chunk that you separated, you can, let's go here, and then I go back to the embedding mode. You can actually, you are able actually to retrieve what interesting content or what relevant content you want to, that is for regarding to the user prompt. So if I do ask about which program language do I use, I will transform my question into vector using the same embedding model. And then on the vector database, once it is a number, I will try to find whatever chunk of text that is related to that prompt. And then I can only add the content that is related to the question that I'm asking about. And then the model can have the whole context to answer as expected. So let's go back here to the embedding model. And what is embedding model? How it does work? So embedding model is another model, also neural network, that does give the following aspect. It is trained to transform a text or text into numbers, and these numbers, for whatever have some similarity on their semantic similarity, they put it, these models usually try to put it closer, and as much as they are not related, it put the numbers as far as possible, or as far from each other. So taking an example of the word apple, if I try to find something about apple, I will probably be placed closer to the fruit apple, and also the company Apple, because both are Apple, right? Depending on the on the context, probably depending on the context, this apple might be closer to the company or closer to the fruit. And the Apple company also probably might be in some vector, in some dimension, probably will be placed close to the Google company because they both are big techs. And the fruit, Apple probably close to other fruits in some dimension because they are also have closer how can I say, closer semantic meaning, closer meaning. Okay, and the same for the word kitten, probably close to cat. And this illustrates better if we do when we do select a word or that chunk that we created here. We do look around the word or the text that I generated and capture whatever is close to that point. So that is how this embedding model works. And in the end, this is a 3-dimension view because it's the only way to represent this view. But these models are models that has hundreds of dimensions, and so they capture hundreds of aspects of the words to make it work better for this semantic search. So that's the way how it works on RAG, and let's take a look on the code how it can work. So here, if we go to the code, we have the test for RAG. So here I have the chat model, and now I have more friends here. I have the embedding model that I talked for. I have the embedding store that will be our vector database. This is an in-memory vector database for the example. I have a document that is news PDF. I just get today this news page from the Hacker News, the RSS or the simplified view, because just to eliminate too much content, okay? Just to make it simpler to work. And then I create this content retriever that is a utilitarian class to whenever I write some message, it can return for me the chunks that is close to that message. Okay, so with that content retriever, in the end, I do create this document assistant that is nothing else than when I do receive a message, I do find the content retriever, the relevant content, and send to the chat model to have the correct results. So here, let's just run it, and then I can go inside these classes to understand the implementation. So here I do ask what the news says about AI. And that's an interesting question, because AI, I haven't actually said artificial intelligence, right? I just say AI. So I'm relying on the embedding model to understand this. This is not any AI in the words, okay? It's just the artificial intelligence. So let's see what it does retrieve. It can take a bit because of the LM Studio. Let's see. It's generating. And while it's generating, any questions so far? Easy peasy?
Have you seen an improvement of training a local model on a specific subject over like an online model?
Mm-hmm. Yes, and that's what we call fine tuning, and they're really got interesting to work with them when you you need to avoid this hallucination that we were talking before, right? When you specify the domain or the output that you expect for this general model, they usually tend to be more consistent on the response. And that's why fine-tuning starts to become more and more common, especially for enterprise applications that they need this kind of consistency, or more consistency than any other application, right?
I mean, is that what they call agents? Just like a very fine-tuned LLM that is an agent that has very long context. It's a Spring Boot agent, a Java agent that you can just hit and has a very long context.
Actually, yeah. Actually, agents, when we say we have the fine-tuning, it is a technique to specify some model to behave regarding to some specific content or domain. And we have the agents. The idea of agent, it is a bit different because the idea behind it is to give some autonomy to make some actions or decisions. And of course, they can do many different tasks. And what we call multi-agent is when we do have a lot of these agents that can do different, they are specialized on different tasks, and they can work together to accomplish some complex tasks.
So agents are things that can execute things, not necessarily long context.
Yes, not necessarily long context.
Got
Can execute things and then and in a way that is more autonomous and less.
So long context is more of a senior answering all your questions, but an agent is a junior going off and executing the things you want it to execute.
Actually, the agents are not also not restricted to short context. You can send long context. It all depends on how the agent is implemented. But the idea behind it is okay, I have an agent that is a professional that summarize some content, and probably this kind of agent will receive a long context and be able to summarize it. And they have some not just rely on the model, but also on algorithm, on some pre-processing, something that can handle it and work with the model to give some proper answer. And when we do talk about long context, to handle it, if it doesn't fit into the model, it is you do pre-process it to use some technique like RAG that can actually select the most relevant content and just send the most relevant content to the model without having to send the whole context. So the model aren't able or are very slow to process that. I hope it make sense, Randy?
Yeah, totally. I'm just putting it all together.
Okay, cool. Well, if now it does reply to me. So based on so it does identify that it's a heterogeneous front page stories, and also stories from 20th to 21st, 2025. Cool, and also about points about AI in the news, and then it picks some of them. Security concerns. DeepSeek R1, TikTok, cursive handwriting recognition. So let's see if they are correct. Security concerns. Sneak security. Yeah, it's talking about the sneak security. Let's see if it's the correct thing. Zero click, then the anonymization targeting sign out Discord. Oh, zero click. Oh yeah. Oh, and it's called. This is a security concern, but there's no security concern word, but it does identify that it's a security concern topic. Also here, DeepSeek R1, let's see. Yeah, DeepSeek R1 comments. I don't know how, but it has identified that DeepSeek is probably this AI might be move it to this conclusion. National two Hacker News shares about DeepSeek R1. Oh, there's one more. Oh, there are two sources. No, just one. Interesting things. It added lots of things that is not on the news, but yeah, it does identify that is an AI news about TikTok as well. Yeah, news about TikTok. So it doesn't. We can see that it took the news from the PDF from the content that I just generated PDF from, and how it works behind the scenes. I think that's the most that's important thing to know. So the problem is that if you see here how it works behind the scenes, you see that is most of the code are handled by the Langchain. So there's not much code from my side. I just created this document assistant and set up the content retriever and the chat model inside this AI service, and then the Langchain does all the things to work with this workflow, right? So once I have the AI service assistant with the content retriever, the Langchain4J, whenever message I do send to this implementation, the Langchain4J will run this workflow. That is, when I ask anything, we'll use it will send the message to the content retriever that will use the embedding model to find the vector database and then retrieve the user message plus whatever it finds on the vector database. And the vector database, if we see here, there's one thing that I prepared here to make it work. If we do use the content retriever here, I set up the embedding model, the embedding store, and give the document here to be stored in the database. So this is one part that is very important for every work we're gonna do with this RAG or any content retriever. It is, how do I actually split the content here? Split the content to make it work better for my use case. And for this example, I just split by the size of the character. So I got 700 characters for each chunk of text. And I'm working with an overlap of 100 characters. So I have this 0 from 700 and then the 600 from 1,013 1,300 and so on. So that is a naive way to split the content. But depending on the content that you're working on, this might not work well. So you have to think about a better algorithm to split smartly the content here. Okay, that's a very important step that far important than the model itself that you're going to be using here. Yeah, and any questions so far? I'm asking because this RAG is not complex, but it's a lot of content. Okay, so a lot of things that we are using here to make it work. But if it's all fine, we can move forward. And another very interesting feature for these models are tool or function calling. So as you might know, these models just receive string and return string. They don't do any calls or external calls during the inference time, during the processing time.
I mean, this is what I asked earlier. But I mean, you said that it uses DeepSync from China?
From no. The DeepSeek, it's the news about DeepSeek.
Yeah, DeepSync is AI from China, right?
Yes, it is. But they just mentioned it because of the news. Not that I'm using DeepSeek here. I think I haven't tried it yet. But the function call, it is not something exclusive for these reasoning models. We can achieve it with this GPT-4, 4.0, and GPT 3.5. They already have this feature available.
I mean, sure, but I mean, are we training all these models with this tool?
Oh, yes.
As we're going back to what you're just talking about, external calls.
Yes, they don't do external calls. But they are able to. You see that on the ChatGPT, for example, if you ask it to do some web search on the internet, how does it actually work? Because those models doesn't do a call for Google to search something on the Google to retrieve you some information from that. So the big idea here is that the same thing before. It is the application that actually handles it and understands that it needs to do some action for the model to have the right context. So if I go here, for example, let's get the example of the web search. If I go here and ask it, oh, what is the latest news about AI on the internet, on the Google? And what we do actually, what the application does actually is, answer this user question. And if you need to do any web search, I have a tool, and you just need to reply for me, search about blah, about something. Okay, and then the model having both the question and the context about the tools, it does actually reply for me. It will understand. It will decide that to answer the user question, it makes sense to make the function call before, and then it asks me. It replies me to the function call with the query on the Google. So I understand because it does reply in the specific format that I mentioned it here. And then I do the search on the internet with the query that the model defined. And then I do add the context for the message, for the array of messages, and then send all back to the model again. So the model is able to actually reply, having the whole context into the whole message. So if we do want to see something similar working, we can go here also on the test and go to the test 5, that is tools. Same thing, I do create a chat model, and I created something I called search assistant, and I called it search latest articles about Java and generative AI in Google. So let's see it working first, and then let's go to the detail. I think I can also, let's see. Oh yeah, it doesn't have to, I have to figure out how to receive the request here. But that's an interesting thing here. It does code search at Google with Google search Java plus generative AI, because it does reply to me to the tool called search Google tool, and with the argument Java generative AI, and with the returned response, it generated the final response here. So here's the latest content from our knowledge base about Java and generative AI. And then it returned to me generative AI in Java, comprehensive guide, introduction to generative AI with a Spock, and blah, blah. So what happens here? When I go here to the search assistant, I do actually define some code here. One of them is called search tools, and search tools, what it does, it has a public method with annotation here that specifies search after content in Google, and then I also specify a parameter here, a search query, and once I receive a query, a string query, I do validate if it's a valid query or not empty query. And here's a code that is a code that I created here to actually do the search on the Google. Okay, so I do place query, replace spaces with plus, and then just send the request, HTTP request, and get the contents. That is the title and the description of the content. And then I return for the response, I return all the titles and descriptions in a single string or in a list of strings. So once I have this tool defined in my own class, I can actually create a AI service that use the chat model, and always when I do ask any question for these assistants, it will also send the search tool definition. So it will send this search after content in Google, and that receives a string argument that is a search query. If we go here on the first request our chat model did for my model, actually it is, or the first response the chat model created to my client, to my question, it was, make a tool call of the search Google tools with the argument Java generative AI. So it is, first it asked me to make a tool call, and then with the response, it was able to create the end answer for the user. So this is the whole workflow of how function calls or tools actually work. And yeah, we can experiment with any other questions here to make it search for other kind of content. It was I think that's the most interesting feature for working with these models, because with that we can actually, the model doesn't make the call, but we can actually provide him or guide him to, if they need something else from outside world, they can ask for it, and I will give you the content or the context of these results, and ask it again for you. And that is what it is, everything that this Langchain4J does for me. It will do loop these function calls for me until the model decide that it can actually answer with the proper contents. Make sense? Oh man, I think I have passed too late here.
Well, a couple of the guys had to drop off, but you're okay.
Okay.
Still here.
Oh, thanks, Randy. Actually, I see the time here. It's already I think it's 9 for you.
I think it's just the three of us left again.
Okay.
So we will end where we began.
Cool. Well,
I really do
go ahead.
appreciate everything you said. I've learned a lot.
Well, that's cool, Randy. Thanks for keeping it here. And yeah, if there's any questions regarding to that, I think that's the all features that I wish to talk about. And
I'm
yeah,
just super suspicious about training AI as we use it, right?
yeah,
Like,
yeah,
I mean, it's a great thing for us, right? If it does make human life
easier,
better, right?
better. Yeah, yeah.
But also, if it makes it worse, we're just training our worst life. So, I mean, we all feel this, right?
Yes, that's true.
I mean, you feel it, I feel it, everybody here on this feels this. It's just like these models, this AI, the intelligence. I mean, we got the intelligence when I moved off of Vim to an IDE, right?
Right.
What is this suggesting to me?
Mm-hmm.
Like, why is it suggesting it to me? We've all been dealing with this for many, many years. It's just getting much more complex.
Yes, it is. And yeah, that's a whole another level of intelligence, right? It creates lots of generates much more, and yeah, it's a double-edged
Oh,
tool.
I mean, I
in order,
used
yeah.
it in a very specific context for a while,
Mm-hmm.
and I felt like I got dumber in that context because I didn't have to think about it anymore, right?
That's
And
true, man.
then
Yeah.
and then I came back to a thing it couldn't solve, and I was like, oh, I haven't thought about that for a while.
Right.
Someone mentioned it before. It was like the Google Maps when we do
Yeah,
Google Maps. We do know
yeah,
the
absolutely.
name.
I lived through that.
Now I can't remember.
I'm Gen X. I grew up with my parents teaching me how to use maps and compasses. Honestly. And then all of a sudden someone gave me a map on my phone that I didn't even have to, or my car, I didn't even have to think about it anymore. I mean, like you get dumb for a while and then it's like you get lost in the city, the internet's out for whatever reason. And
Yes.
you can't I used to be able to do this.
Anymore.
I can't even get home. I used to live in this town. I should be able to get home. Yeah, so I mean it does there's a dual-edged sword that we're all living through right now, and I think we'll all land on the right place. Right?
That's true, man. Yeah, that's totally true.
Thank you so much. I again super suspicious of all these AIs, local LLMs. Right.
Yeah.
Can I apply that to my development environment without it transmitting any data?
Good. Yeah, good question. I
Yeah.
think the reliability is the same as do you rely on your ID to not sending the content to
Oh,
anyone else?
we all do this all day long. We log into a website, GitHub,
Yes.
all of it, right? I mean, they literally list that Git is their source of their code, and we're all putting our code in Git.
Yes.
Like, right? So you huff and you puff, but we're already using the iPhones. We're using,
Yeah, totally.
everything is online. If Git goes down, if Okta goes down, we're all just like, oh, we're just stuck. Can't do anything more now. I can't commit to Bitbucket. Nothing, right? Like if these services go down, we're all just stuck.
Yes.
Right. And that wasn't I mean, if a service went down 20 years ago, you're like, I'm still coding today. Like, and today a major service goes down and we're all stopped. Right. I mean, you can't authenticate. You can't. Yeah, it's just crazy. It's a crazy world. And it's a crazy world I want. Like I like, why are we on a unified language now? I mean, we're in Star Trek world. Like, why are we all on one language?
Yes, yeah, that's a longer discussion probably.
Oh, very much so, right? But
Yes, yes,
I think that's where
much
we all
longer.
end up, right? In a few years. I don't know. I mean, because they're such specialized languages. But anyway, thank you
Yeah,
so much.
yeah, okay. So if just to keep it just to get the recordings here, yeah, the presentations. If you like the content, I wrote actually an ebook to to summarize, not summarize, I think actually is to go into more details over this, over everything that I talked here on the presentation. So if you want to have access for that, just subscribe here on the Sandbox, and then I will send a message with this ebook. And yeah, I'll be happy to connect with you as well if you have any further questions.
Absolutely.
So, Randy, thanks a lot. And yeah, I see that Dunsline asked here to send out the presentation. And yeah, I can totally provide the presentation, Dunsline. The content on the ebook is actually the same thing of the presentation, but with the text and details. And yeah, if you are interested in, you can take it from here. And yeah, the YouTube, Scott will actually send the link, right, Scott? I think he had to. Oh, you're back. Okay.
Yep. Sorry, I couldn't wait any longer.
Okay, sorry. Go ahead. Yeah, so I think it's I finished here with the content. Sorry for, I think I take much longer than than expected.
Oh, no, this is good. We give you plenty of time to speak, and so I appreciate this. This was helpful stuff, and I will do my best to have the recording up on YouTube tonight if anybody wants to see it. So,
Ooh.
and here's your ebook.
Yeah.
On that's pretty cool. And thanks again, Yugo. Really appreciate it.
Thanks. Yeah, I just want to thanks again. Thanks you, Scott. Thank you, Randy, and everyone from the Houston Jug. And yeah, hope to have new opportunities in the future.
Excellent.
So,
all right. Well, we will leave it at that.